Welcome to chemical mixture problems. Basically, what we're going to do is I will set up a couple of videos to go through some of these mixture problems. They're oftentimes referred to as chemical mixture problems because that's oftentimes what you are mixing in these word problems. With any word problem, you want to read it, annotate it, set up some kind of equation based off of the annotations, and then solve the equation. So if we take a look at problem number 1, we have one solution that was 90% iodine. Another was 70% iodine. How much of each should be used to get 100 liters of a solution that was 78% iodine? There are lots of ways to organize your information. You choose what makes sense to you. This is going to look a little goofy, but it's what makes sense to me. I think of chemical mixture problems, and I think of the beakers from chemistry class. I don't draw well, so we have one beaker plus another beaker is going to mix to create what I'm trying to make. Now, to stay organized, you want to basically pick one of these two spots. You have a little oval at the top or the kind of rectangular part at the bottom. One of those takes all of the percentages. The other one will take all of the quantities. So just don't try and mix and match them, but make sure that you follow the same pattern across. So it says one solution was 90% iodine. We're going to add 70% iodine to that, and we are trying to create 78% iodine. Okay, so that's all of my percentages. Again, I picked the oval at the top for all the percentages. That's what I'm going to use it for, okay? The second thing you want to look at are your quantities. So it says one solution was 90% iodine, another was 70% iodine. How much of each? So I don't know either of these two. So I'm going to leave these two blank for right now. But I do know I'm supposed to end up with 100 liters. So my final product here is supposed to be 100 liters. I'm going to go ahead and zoom in on this a little. So I'm going to pick my favorite variable in the whole wide world, and I'm going to say that I am going to use 90% and X liters. Okay? I don't know what I should end up with, or how much of this to use. What I do know is I'm supposed to end up with a total of 100. So if this is my total, and I've used up X in the 90%, the 70% would be 100 minus X. The total, right, 100 minus the quantity I've already used up. This prevents us from having to deal with a two-variable equation. You could have used X and Y here and solved this with a system. I do not recommend that, but it is a possibility. Okay. The other thing is these two quantities could be reversed. You could have X here and 100 minus X here. It will just change at the end what you associate your X with. All right, so we've done all this work. We've organized everything, right? We annotated the beginning. We've basically, for me, this is drawing a pretty picture. The reason I organize my information this way is because the chemical mixture problem falls directly out of this setup. So you're going to take your percent times your quantity plus percent times quantity equals percent times quantity. And I'm pretty sure you can solve from here, okay? At this point, you have basically a straight linear equation, all right? And so there's no surprises, no weird things happening, but you do need to solve it. So let's see what we've got here. 90 minus 70 is 20x. I'm going to go ahead and subtract 7,000 from the other side, so I'm going to get 800. So x equals, what's 800 divided by 20 here? Let's see, 800 divided by 20 is 40. Okay. So x represented the quantity of the 90% iodine solution. So I am going to write this out as 40 liters, helps if I put the R in liters, of 90%. And it did ask how much of each. So what quantity do I need to use for the 70%? Well, I'm going to take 100 minus X, and that would be 60 liters, okay, liters of 70% iodine. And you've just solved a chemical mixture problem. Okay, now this is another type of problem. Like the border questions, not all of them follow the exact same format. So what you want to make sure that you're doing for each one, read it, annotate it, and make sure whatever you do to organize your information follows what's in the problem. Okay, so if I take a look at number 2, how much pure acid must be added to 180 grams, that is 35% acid, to produce 50% acid. Okay. So again, these look a little goofy, and if I draw them too fast, they look like little muffins, and that's okay too. All right, so starting with, we're going to add some stuff to it, and we want to create some stuff. Okay. How much pure acid must be added to? All right, so I'm starting with a 35% acid solution, and I want to add pure acid. Well, pure acid is 100% acid, and you're trying to create a 50% acid solution. Okay, so that's all my percentages across, and now I want to look at quantities. So I have 180 grams of the 35% solution. How much pure acid? I have no idea, but X it is, all right? So I have 180 grams. I am adding X grams, so my final quantity is going to be 180 plus X. So that word problem just translated into this plus this is equal to this. And again, this is how I make sense of the problem, because from this setup, I can immediately write the equation and I can solve it then. Okay, so percent times quantity plus percent times quantity equals, guess what, percent times quantity. Okay. 35 times 180 is not going to happen in my head, so my calculator just told me it's 6,300. Plus 100x is equal to 180 times 50 is 9,000 plus 50x. All right, we do two things at once. I'm going to move the 50 over, so 100x minus 50x is 50, and 9,000 minus 6,300 is 2,700. Divide both sides by 50. I get x is equal to 54. So how much pure acid? Well, x represented how much. So this is going to tell me that I need 54 grams of pure acid. I believe the abbreviation for grams is just G. I always forget it, though, and so I just write the word grams. Use the abbreviation if you know it. All right, I'm going to go ahead and do number 3 as well. Again, I will probably break up this video at some point just so it's not super, super long. Okay, so problem number 3. How many pounds of water must be evaporated? Ooh, that's interesting. From 50 pounds of a 3% salt solution, so that the remaining portion will be a 5% solution. Okay. We got some weird stuff going on here because we've got evaporation. So let's start with what we're literally starting with. So evaporation means we are going to be subtracting, right, some amount here, and we're going to create our final solution. Okay. We are starting with a 3% salt solution, right? And I'm trying to be very articulate and very clear about a salt solution, because if we're talking about evaporating water, water is 0% salt, right? Water is pure water. It's 100% water, 0% salt. So be careful about that, okay? And we're trying to create a 5% salt solution. All right, so 5%. Let's take a look at our quantities. In this case, we're talking about pounds. So we have 50 pounds that we're starting with. How much are we evaporating? I have no idea, right? I don't know. But if we're evaporating it, that means our end product here is going to be the 50 pounds we started with minus how many pounds we evaporated. Okay? So a little different on this setup because we have the pure water and the other percentages are dealing with salt. So we want to be careful that we get all the percentages in terms of salt. 3% salt to start. You're evaporating water, which is 0% salt, and you're trying to create a 5% salt solution. All right, so let's write an equation here. Getting one step ahead of myself there. Minus 0 times x. That I like in this problem. Okay, so 50 minus x. All right, so that's 150. 0 times x is 0. Subtracting 0 won't matter, so we're just not going to even worry about that 0x part. Let's see, this should be 250 minus 5x. Okay. Make sure I didn't do something goofy on that. I did not. Awesome. So I'm actually going to do two moves here. I'm going to move the 5x to the left and the 150 to the right. So 5x becomes positive. 250 minus 150 is 100, and 100 divided by 5 is an x of 20. All right. So how many pounds of water must be evaporated? 20 pounds of water have to be evaporated to concentrate that 3% salt solution to a 5% salt solution. Okay? At this point, I'm going to go ahead and cut this video. I will pick up where I'm leaving off, so problem number 4 in the next video. As always, if you have questions or concerns on these, let me know how I can help.